Hi, this is Sean. I am the National Technical Expert here at GenX, and today we're going to make some videos for you to show you how to do a density test on site. Not only because they're mandatory, but they'll teach you a lot about your foam, its property and its qualities, and your density and how it relates to your yield of the material, which is much more important than just doing it because you have to. So generally, you'd want to take your sample from your application area, whether it be a wall, a ceiling, or a floor. That'll give you your best results. Very important when you're making your sample for your density test that you do not have pass lines. Once you take that sample out, make sure you remove any skins or any substrate that came along with that sample, so you get a clean, pure foam with no other elements or skins on that sample. That sample, you refine it, get it down so it fits into your graduated cylinder. Okay, so once it fits in there, we know that it's going to fit. What we're going to do, we are going to weigh the sample once we know that it fits into our graduated cylinder.
Let's take a break from Sean, shall we? Site measurement is difficult. There are a lot of variables that can change your tested result. Dirt on the scale, wind across the face of the scale. And here's one, static electricity. We're all familiar, it happens. If it happens to your sample, it will change the density significantly. Let me show you. If I weigh the sample, it's 6.8 grams. If I create static electricity, the weight changes to 7.4. Now, here's a quick tip. Use an insulative material like a paper cup between your sample and the scale. Put the paper cup on the scale, tar your scale to 0, and then weigh your sample. 6.8. Hope that helps. Just a tip. And back to Sean.
And once we get that weight, we're going to record that weight. We're going to say that this weight is 6.8 grams for our sample. So now what you've done is you know how much this sample weighs. Now you want to check the displacement of the sample in water to give you a volume. Now, keeping track of what your milliliters are before you start, here we have 700 mils. When we completely submerge our piece, we want to look at the difference in the number from the 700. So if you do some simple math on that, you're going to find that now we have 9, we started with 7, you're left with 200 milliliters of displacement, and that is the volume surface area of that piece. So now we can start doing some math. Everybody's got a phone. You can use your phone. You don't necessarily have the calculator. This is going to do it for you. And another key factor is on the GenX website, you could find we have an app just for these daily work records, and it helps you with this math as well. Some of these key numbers that you're going to need are in there. So you can find that on the website and use that application. So once we start doing some math, we know that our weight is 6.8 grams. We know that our displacement is 200 milliliters. So if we take our weight and we divide it by the 200 milliliters, so right now we ended up with a number with 0.034. So we'll times that by 1,000 to move our decimal point, and we get a number of 34. That 34 is our kilograms per meter cubed. Our minimum requirements for our per meter cubed are going to be 32. So we're already over that, we're at 34. Now if we want to convert that number and move it down into a pound per cubic foot, we would take our 34, divide that 16.02, and you don't have to memorize this number, you will after a while, but you'll find it once again on your GenX app on your phone or on your daily work record. That math and those numbers are provided for you on that sheet, just follow it there. So once we take our 34 kilograms per meter cubed, divide it by 16.02 to convert it down to a pound per cubic foot, we're getting 2.12. So that is our pound per cubic foot. And our minimum requirements for our GenX material is 2.0. So we have to make sure we're over and make sure we're not under, because now you're changing the physical properties of the material. You're basically not selling the customer what they're paying for. If your densities are too high, what you'll find also is you're not yielding very well. So density is a key indicator on your yield, how far you're stretching your material, and whether you're making money on that job or not. And that should be more important to you than just doing this test because you have to. Using this and implementing with daily techniques of your color of your foam, your wet line, your substrate temperature, and everything else will really refine you and help you dial in your material, give your customer the best product, and also get the best yield out of your product, which is going to benefit you the most. So thank you for watching this video. If you need any other support, technical advice, don't hesitate to reach out to me or anybody at our team at Genec. We'll be more than happy to assist you. And once again, pull up that app, get it on your phone. It's so easy, convenient. Minimize the pen, minimize the paper, send it directly to your customers directly from there. It just refines the whole process. And once again, you don't got to try and remember all these numbers. We'll put them in there for you to make it easier for you. Thanks for watching. Take care.